Hi, welcome to my channel Cloud with Girish. In this video, I'm going to show you how to build a serverless generative AI solution to create call center transcript summary via REST API, Lambda, and AWS Bedrock Converse API. I have posted a similar video with detailed steps on creating a GenAI solution for summarizing the call center transcript by passing a transcript file that contains the conversation between a call center support staff and a customer. However, in this example, I will further extend it by adding the function to protect the customer PII information so that this information is abstracted from the response being written by Amazon Bedrock Converse API to the end consumer of the API. Example of PII. PII stands for personal identifiable information like social security number, account number, phone, email address, etc. Amazon Bedrock, as we know, is fully managed service that offers choice of many foundation models like Anthropic Cloud, AI21 Jurassic 2, Stability AI, Amazon Titan, and others. I will use recently released Anthropic Haiku Foundation model and will invoke it via Amazon Bedrock Converse API. Here is our business use case. There is a transcript available for case resolution and conversation between customer and support call center team member. A call summary needs to be created based on this resolution conversation transcript. An automated solution is required to create call summary. An automated solution will provide a repeatable way to create these call summary notes. Increase in productivity as team members usually work on documenting these notes can focus on other tasks. Guardrail should be configured so that PII information is not displayed in the response. I will be creating Lambda function via infrastructure as code approach using AWS Server Application Framework and CloudFormation. However, you can create the Lambda function using the AWS console as well. Here is our architecture design. We have a user or a consumer app which is invoking the API. We have AWS API gateway configured. We're going to pass the call center transcript file as the prompt to a Lambda function. And Lambda function is actually invoking the Bedrock, and Bedrock is invoking the underlying model and getting the response back. In this particular example, we have extended the function to use the newly released Converse API as well as Guardrail, which will be configured to protect the PII information. Prereq for this workshop is simply familiarity with AWS console, transcript of resolution conversation between customer and support call center team member, knowledge of Python Boto 3, knowledge of AWS Lambda, basic familiarity with generative AI and foundation model concepts, and basic familiarity with Amazon Bedrock Guardrail. Let's get started. We're going to review the Bedrock service. We're going to review the foundation model. We're also going to review the Converse API and Bedrock Guardrail. We'll request the model access, look at the playground, look at few key terms. Then we're going to look at the SAM template and the Lambda function, and we'll build the function using AWS SAM, and then we'll test it locally and deploy it. And finally, we'll validate the generative AI model response using a prompt. I'm going to use Postman to validate the API and the response. Like I stated before, I'll be creating the Lambda function via IAC approach using AWS Server Application Framework and CloudFormation. However, same can be accomplished using AWS console. SAM is a powerful tool for developers to develop and test Lambda function and API endpoint locally before deploying them to the cloud. If you want to learn about creating and testing Lambda function using AWS SAM, please watch my video on Lambda workshop. Link is in the description. Let's look at the Bedrock service. Amazon Bedrock is a fully managed service that offers choice of many foundation models, and it's another serverless offering from Amazon. So it's allow integrating with popular foundation models, also allow to privately customized foundation model with your own data using the AWS tools without having to manage any infrastructure. Let's revisit what Amazon Converse API is and why it is needed. So you might be wondering why there is a need for another API when Bedrock already supports invoking model for large language models. The challenge that Converse API aims to address is the varying parameter required to invoke different LLMs. It offers a consistent API that can call underlying Amazon Bedrock Foundation models without requiring changes in your code. For example, your code can call Anthropic Haiku, Sonnet, or Amazon Titan just by changing the model ID without needing any other modification in your code. While the API specification provides a standard set of inference parameters, it also allows for the inclusion of unique parameters when needed. As of May 2024, the newly introduced Converse API does not support embedding or image generation model. Let's look at what is Amazon Converse API Guardrail. So Guardrail is very important. So generative AI guardrails provided by various generative AI solutions are one of my favorite functional areas to read about, validate, and prototype. These guardrails transforms a generative AI solution into a responsible AI solution by ensuring that responses stay within predefined boundary and guardrails. Examples include abstracting personally identifiable information, referred as PII, or preventing an API or chatbot from providing information from restricted area, such as account details, investment advice, or any other sensitive data defined by the organization by implementing these guardrails. Amazon Bedrock initially supported the guardrails for invoking foundation model. As of June 2024, similar support has been extended to the Amazon Bedrock Converse API. I will implement these guardrails in a previously completed project involving the transcript summary for a call center. In this use case, the generative AI response to the end consumer will abstract any PII information. Let's look at a few other concepts around Guardrail policy. So the Amazon Bedrock Guardrail feature allow you to configure various filters, providing responsible boundaries for the responses generated by your AI solution. These guardrails help ensure that the outputs are appropriate and aligned with your requirements and standards. Example of filter, there are content filter across 6 categories. So those are hate, insult, sexual violence, misconduct, prompt attacks. Filter can be set to none, low, medium, and high. There are denied topics, so you can specify topics which should be denied. There are word filter, you can specify words that you want filter to act on before providing a response. And then there is a sensitive information filter. This filter is to either block or mask the personal identifiable information, the PII information. This is the filter that I will be using in this workshop to prevent the AI to provide information or put the PI information in the response. So Amazon Bedrock allow a way to configure the message provided back to the user if input or the response is in violation with the guardrail configuration policy. For example, if sensitive information filter configured to block a request with account number, then you can provide a customized response letting user know that request cannot be processed since it contains a forbidden data element. This is just a view of various choices of foundation model. Like I stated before, Amazon, Anthropic are my favorite ones. There are other models like AI21, Cohere, Meta, Mistral, Stability AI for image, and so on. Let's look at the requesting the model access. If you don't already have access to the model, first thing first you need to do is request access to the model. Typically, it takes few minutes to few hours depending on which model you are requesting. There is also Playground that Amazon provide as part of Bedrock offering. So here you can validate, you can look at your parameters, you can pass the prompt, look at the results and so on. I will not be using the Playground because I'm going to use Bedrock API to provide prompt and then get the response back via the API. Few key terms. If you have watched my other video on generative AI, you probably already know these terms. These are important, so I leave it in every workshop here. Temperature is a value of 0 indicate less random generation. If you have a value of 1, means more random generation by your AI model. Top P, if value is less than 1, it will have less probable set of tokens. And then max token count is important. It indicates max number of tokens to generate. Responses are not guaranteed to fill up to the maximum desired length, but tokens are factor in the overall cost. Hence, it is worthwhile to pay attention to max token you want to use. Let's look at our AWS SAM template. So in this template, as you can see that I have some environment variable defined. I also have my runtime as Python. I have some policy for the execution and some permissions here. And also like I'm defining a API event in this SAM. Here is the look at AWS Lambda function. I got a function inside the Lambda. I actually can put it as part of a helper class or a util function. But for the sake of simplicity, I have it all under my Lambda. And we have a create guardrail. So I'm actually creating the guardrail through the Boto3 Python code here. I could have created it using AWS console because it can be separated out. You can create a guardrail and then you can reference it in your code. But in this example, I have a function create guardrail. I'm defining my guardrail here for the sensitive information configuration, and then I'm creating it as part of this function. I do have a condition set here that if guardrail is already created, then skip that part of the code. And that's simply for the reason if I execute this Lambda function multiple times, I don't need to create the guardrail that many times. Also, then I have another function here, which is generating generate conversation. And this function, I'm building my inference configuration, my message based on the prompt. And then I'm also invoking the Converse API, getting the response, and then I'm returning the response back to my Lambda handler. This slide here, let's look at the subtle differences between the invoke model and Bedrock Converse API. Invoke model is still supported. It's another way for you to invoke the Bedrock API, which will again you use the underlying foundation model. Converse API, that is the newly released API, but if you look at it, for the invoke model, we have to build our prompt, we have to provide all the config, and then we invoke it via the runtime invoke model command. For the Converse API, similar steps in a simpler way. So we build our inference config and then we invoke the Converse API. The benefit here is the interface is consistent. So we can, like I said, change the model ID and invoke it for different underlying model. One thing that you do have to pay attention, because it's a newly released API, it requires Boto3 1.34.116 or higher. So if you don't already have it, you will have to update your Boto3 library, otherwise your code will not work. Once we have the function, I will build it using the SAM build command. And once build is succeeded, I can validate it locally using AWS SAM. And the command for that is SAM local invoke, my function name, and then I'm going to pass a event payload. Once I have validated it, I can deploy it to the cloud using the SAM deploy command. and I can also validate it through Postman. So once my API is all good, I can pass my endpoint here. I pass the transcript file, and then I should get a response back. So let's look at the example of the response that I'm getting back here. I have a response that I'm getting back from Anthropic Haiku based on the transcript file, which was a conversation between the customer and the call center support staff. Model had generated a summary of the conversation, and as you can see, the conversation was about customer calling the uh, technical support line and speaking with the representative about a lock account, and then the call center support staff asking few questions and helping customer resolve the issue. The second example here, if you see, I have the guardrail policy, and if I update the policy to say that if there is a account number in the request, then it should block it. That's the scenario that you will see here, that guardrail is enabled. I have updated the guardrail here through the console, and I'm saying, hey, rather than masking or not showing the information, just simply block it. And when I do that, you will see that message I'm getting here is that it contains sensitive information and cannot be processed. And then I'm extracting that which data element actually got blocked. And as you can see, based on my policy, US bank account number got blocked, and my stop reason is that guardrail has intervened. So this is a really good example of that, how you can protect the sensitive information from the response and not leave it wide open by implementing the appropriate guardrail around Bedrock API. And then that's how you can have somewhat control on the responses that's being generated by your AI model, and you can protect the information based on your organization policy, standards, and other factors. CloudWatch log, simply showing the logs that showing what model I'm using, what the response is, what the request is, and so on. It's really based on all the logger statements that I have in my Lambda function. With that, let's see it in action actually. So let's see it in action, and I'll show you that how I'm invoking it and how we're getting that response back. All right, we're gonna see it in action. I'm in my VS Code environment. I have my project open. So as you can see, the function that I was talking about, we got our create guardrail function here. We have, this is our create guardrail function that's creating the guardrail. We have the generate conversation, which is gonna take the parameters and invoke the Converse API. And then we are returning the response in the Lambda handler. So let's build this function locally using the AWS SAM, which is the serverless application model. So we're gonna build it, and once build is successful, then I can locally start the API, and then I can validate it using the Postman. So my build is succeeded. I'm gonna test it locally. So let's start the API, and then once API has started, I'm gonna validate it using the Postman. Okay, I'm in my Postman now. I have the API endpoint. I have a transcript file that I'm gonna pass it to the API. So let's send it, and we're gonna see the response back here. So see, here is my response, and as you can see that my conversation here has been summarized by the model, and API is returning the summary. Here is how our policy currently looks like. We are masking, asking model to not return the data element in the response, and that's exactly as you saw that the API response did. It did not have like the address or the account number information in the response. Let's update this, and what I want to do is that I want to block the account number. So we will make it block and save, And I'm going to go back to my API in Postman. I'll run it again and let's see the response that we're going to get. So I'm back in my Postman and I have the previous response. I have updated the guardrail to block the account number. Let's see if I run it again. This time I expect the response to tells me that it has been blocked based on, and exactly like you will see the response that I just got. It say, hey, your input contains sensitive information, cannot be processed, and it's telling me that account number has been intervened, it has been blocked. So this is a great example of like how the guardrail gives you control and you can configure it based on your organizational policy and then control the responses being written. With this workshop, a serverless generative AI solution to create call center transcript summary via REST API, Lambda, and AWS Bedrock Converse API has been successfully completed. Amazon Bedrock Guardrail has been configured to protect PII information. Python Boto 3 were used to invoke the Bedrock Converse API with Anthropic Haiku model. As GenAI solutions continue to evolve, they are set to reshape traditional workflows and drive tangible benefit across industries. This workshop serves as a compelling example of the transformative power of AI technologies in addressing real-world challenges and unlocking new opportunities for innovation. Hope you have enjoyed this tutorial. I'm working on some other interesting content on various AWS topics. These will be posted soon. Please don't forget to like and subscribe. Thanks for watching.